Okay, so let's just start with a rational function here, and I don't know, let's say that we've got, here we go. So let's say we want to graph f of x equal to 2x squared over x squared minus 1. Okay, so that's what we want to graph there. Okay, and so the things that we want to be able to come up with, or the things that we're going to use to help us come up with this graph. Okay, I'm going to list them out here. The first thing we want to be able to identify is the domain. Okay, then we want to identify any, so ID, any vertical asymptotes or poles. Okay. Then, okay, we also want to identify any slant asymptotes, or I should say any horizontal asymptotes first. We'll do horizontal asymptotes. Space here. Okay, or slant asymptotes. Okay. And then we'll identify any zeros. And then graph / find more points if necessary. Okay. So we have kind of moved on. We've kind of moved on from, our transformations of rational functions. So like the first rational function we looked at, right, looked like this: 1a times 1 over x minus h and then plus k, right? And that was like a transformation of the graph of 1 over x, which just looks like, we have the vertical asymptote there, horizontal asymptote here, and it looked like that. And I went through 1, 1, okay, here and there. All right, so -1, -1. Wow. All right.
I'm not sure what you said there.
You're not alone, cell phone. You're not alone. Okay. What is this class today? What is this class? All right. What even is this class? All right, so these are the things that we want to be able to come up with, okay, right, for this particular function. All right. So for the domain here, it's going to be helpful, okay, for the domain, we want to see, when our denominator is 0. So we want to try and factor this thing. So x squared minus 1, I'm going to go ahead and factor that. It's x minus 1 and x plus 1. This is why we spent that time, learning how to factor polynomials and stuff like that, because we're going to need that skill for here, okay? We, have created a need for it now, okay? And so, what x values do we want to exclude from our domain here? What x values are going to give us problems? 1 and
0. Oh, sorry. 2.
If we plug in 0, we'll have 0 in the numerator, squared times 2, so it's at least 0. At least 0 minus 1, so that's -1. 0 plus 1, so it's 1, so it's -1 times 1, -1. So we'll have 0 over -1. That's still 0, no problem. No problem plugging in 0. If we plug in 2, we'll have 2 squared, which is 4, times 2, which is 8. And we'll have 2 minus 1, 1, 2 plus 1, 3, 3 times 1, so it's 8/3, what that would be. Again, no problem plugging in 2. There's one other x value though. So 1 is a problem, and -1. Why are those two numbers problems? if I plug a 1 into this function, in the numerator, I'm going to square 1 to get 1, multiply by 2 get 2. So I get 2 in the numerator, but then 1 minus 1 gives me what? If I plug 1 here, I get 1 minus 1, which is what? 0. 0 times anything is 0. I'm going to have 2 divided by 0. We can't divide by 0, so we have to restrict the number 1 from our domain. We can't use it. Okay? Likewise, negative 1. If I plug negative 1 in here, right, the x value of negative 1 is going to get plugged in everywhere. But specifically in here, the problem is going to be I get 0 here, which is going to be 0 times that. The whole thing will be 0. I'll have a number over 0, which means it's undefined again. So that's why for the domain here, we don't want to divide by 0. So for number 1, okay, domain, identify x values, okay, that cause the function to divide by 0. Okay. So we're going to exclude 1, negative 1. Okay, so negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. Or you can just say all real numbers, x not equal to 1 or negative 1, like that. So there's the domain. You did the domain. Okay? That's the domain. So then, why do we do that first? Because then from those domain restrictions, from the numbers that x cannot be, we can then determine whether those are going to be vertical asymptotes or holes. They're going to be one or the other, okay? Domain restrictions will be vertical asymptotes or holes.
Wait, so all real numbers except 1?
Except 1 and negative 1. X not equal to 1 or negative 1 there. Or you could say yes, sorry, I see what you were trying to, yes. You could say except 1 or negative 1. You could also say that, sorry, yeah, I see. I did write that slightly different than I have been. Okay, so our two domain restrictions here, that 1 and negative 1. So x equals 1. Is that going to be a whole or a vertical asymptote? Well, what do we see up here in the function? Does x plus 1 does x minus 1 here cancel out with an x minus 1 in the numerator? No, it doesn't. So it's a vertical asymptote. Okay. What about the x equals negative 1? What about that? X equals negative 1. Is that a vertical asymptote or no? Okay, it can be a vertical asymptote. That's right. Again, same reason. It doesn't cancel out. All right, it does not cancel out. So those are our two vertical asymptotes there. All right. Number 3, identify any horizontal asymptotes or slant asymptotes. Okay. So here are the rules for horizontal asymptotes. If the degree of the numerator is greater than the degree of the denominator, I'll put an if there, if the degree of the numerator is greater than the degree of the denominator, no horizontal asymptote. If the degree of the numerator equals the degree of the denominator, okay, then HA, the horizontal asymptote, is equal to the ratio of the lead coefficients. And then finally, if the degree of the numerator is less than the degree of the denominator, okay, then the horizontal asymptote is at y equals 0. Okay. So there's basically two situations where you will have a horizontal asymptote. If the degree of the numerator is smaller than the degree of the denominator, or if the degree of the numerator is equal to the degree of the denominator. Okay. If the numerator has a bigger degree, there's no horizontal asymptote. Okay. Okay. There's no horizontal asymptote, but slant asymptote, okay, exists if numerator is 1 degree more than the denominator. Okay. So a slant asymptote exists if the numerator is 1 degree more, but there's still no horizontal asymptote. You can't have both a horizontal asymptote and a slant asymptote, one or the other. Okay. So with these rules here, let's take a look at our degrees. So what is the degree of the numerator? 2. What is the degree of the denominator? What's the highest power in the denominator? 2. So the degree on the top is 2, the degree on the bottom is 2. So that means the degree of the numerator is equal to the degree of the denominator. The horizontal asymptote exists, and it's the ratio of the lead coefficients. What's the lead coefficient in the numerator? 2. What's the ratio of the lead coefficient in the denominator? 1. So it's 2 over 1. So we have a horizontal asymptote at y equals 2. Okay. We won't be writing this much, guys, for every single problem here. I just want to, spell it out here real, carefully, so that way we're good when it comes to the future problems here. Okay. All right, we're going to identify any zeros. Okay. Set the function equal to 0. Can't write well here. Set the function equal to 0. Okay. Okay. So 2x squared over x squared minus 1 equals 0. Okay. Yep.
Can you move it down a little bit?
Yeah, I'm sorry. Am I going too fast?
Only a little bit, but it's okay.
All right, I'll slow down here. I'll let you get caught up.
What if we just like all leave it left?
Wait.
If the bell rings.
Yeah.
No, Andrew. No.
No fun.
Imagine if you did that. If that's someone that's you would not be very happy.
I probably wouldn't wake up. Sounds don't wake me up.
We just didn't want to touch your
Now we're gonna stay in here.
pre-calculus.
We have things to learn. What's that?
You just didn't want to touch your pre-calculus.
Yeah, exactly. No, it's an algebra 2 book anyway. But no, that's not what it is. Nope.
Are these notes gonna be on Google Classroom?
I am recording it now. Yeah.
I'll just skip to it soon after that.
Before the bell rings about 2 minutes ago, she woke up.
Well, we'll see. Sometimes bells don't wake people up. Anyway, so zeros, okay. Set the function equal to 0.
The folding chair doesn't do that for me.
Okay, so when does a fraction equal 0? When what part is 0? Just the numerator, guys. All right, just the numerator. So 2x squared, we can just set that equal to 0. And so we can solve for x here. We'll divide both sides by 2, square root both sides, and we get x is just 0. And then now we're going to graph and see if we need to find any more points. Okay, and this is what we've been trying to get through, right? What is this graph? Okay, so let's pull out our pieces that we found. Okay, from number 2, we can skip number 1, the domain, we just know, the domain we then came up with number 2 here. So number 2, there were no holes, right, because both the 1 and the negative 1, we couldn't get rid of those in the original function, right, they don't cancel out. And so we have a vertical asymptote at 1 and at negative 1. So in our graph here, I'm going to, graph the number 1 and negative 1. And we're going to draw vertical asymptotes. So there's 2 of them. Okay. So there's our 2 vertical asymptotes. We also have a horizontal asymptote at y equals 2. So what I'm going to do here is I'm going to just use the scale. I'm going to say that's 2. Okay, I'm going to count by 2's on my y-axis just because I wanted to have some space there. Okay, so I'll draw my horizontal asymptote through 2. Okay, and again, the horizontal asymptote, we got that from the degree of the top, degree of the bottom, and the ratio of the lead coefficient. So the degree of the top is the same as the degree of the bottom, ratio of the lead coefficient. And then finally, zeros. And we have a single 0 at 0, 0. So there's a point. Okay? And so now I got to figure out some other points, some other information here. All right? So, oops, I went probably too close there. There we go. That would be 2. And so what I'm going to do is I'm going to start, kind of just moving from left to right here. So I have this vertical asymptote. I'm going to pick this x value right here, negative 2. I'm just going to find what is f of negative 2. So you got 2 times negative 2 squared all over negative 2 squared minus 1, like that. Okay, so negative 2 squared is 4 times 2 is going to be 8 over, and then negative 2 squared is 4 minus 1 will give us 3. So it's 8/3. So I have the point negative 2, 8/3. Okay, 8/3 is a little bit more than 2, right? 8/3 is like 2 and 2/3. So it's almost 3, yeah. So it's going to be somewhere like right up in here, we'll say, is the point. And so because I have this one point here, I know that my graph's going to have to go something like this. I know it's got to go something like that. Because it's just that one point. That's all I needed. And now between here, well, this is kind of a pain because we don't have any nice numbers left. We already picked 0, and then the vertical asymptote is at negative 1 and 1. So I have to pick something like 1/2 or negative 1/2 and stuff like that. So, all right. If I do that, I think, let's see here. I'll use my calculator to help me out with that. Okay. So let's see here. 2x squared divided by x squared minus 1. Okay. So let's see here. Negative 0.5, negative 1/2 is at negative 2/3. So at negative 1/2, we're at negative 2/3. So like we'll say roughly, I don't know, like right there. And then a positive 1/2, we're at negative 2/3 again. So it's like right there. So this is going to be like a parabola.
Yeah, it should be the same thing. Just parabola.
Yeah, it's true because of symmetry there. Okay, like that. Okay, little parabola. And then again, I'll pick 2, f of 2, and we'll evaluate that. And again, it's going to be 2 times 2 squared over 2 squared minus 1. And so I get 8/3. So it's 2 comma 8/3. So 2 and then 8/3. And again, it's going to be like by symmetry. So again, we get this point. And that one point is enough to then just say that's what the graph's going to be like. Okay. So there's a lot going on there. Right? But there's the graph. Okay. Let's try another one. Here. Okay. So let's sketch the graph of g of x equal to x squared minus 9 all over x squared minus 2x minus 3. So again, things we want to find. We want to find the domain. So we'll do the domain first here. Okay. Excuse me. What are we going to need to do with our function here before we start trying to find the domain? Like if you look here at the denominator, what's that? Find the x values that give us 0 in the denominator. The problem is though that denominator, it's not factored. Right? That x squared minus 2x minus 3, we have to factor first. Okay? So we're going to factor this first. So we need two numbers that multiply to make negative 3 but add to make negative 2. Negative 3 and positive 1. Okay? And then the numerator, it also factors the difference of squares. It's going to be x minus 3 and x plus 3. Okay? So there are those two. Aha. Okay. So then according to this function, Josh, can you tell me what are going to be our domain restrictions here? Oh, he is balancing on his... Okay, he is out. All right, this is an exciting lesson today, I guess. Greg, your turn, all right?
I'm going to say it's going to be 3 and negative 1.
3 and negative 1, that's right. Okay, 3 and negative 1. All right, are our two domain restrictions. Positive 3 will give us 0 in the denominator. Negative 1 will give us 0 in the denominator. So we can say the domain is all real numbers. Okay, except x equals 3 or 1 there. Or negative 1, sorry. Okay. Good day, guys. Good day. You guys, just take next week off, guys. All right, just take next week off.
Oh, really? You can grade this down?
Yeah, I am. I'm doing it.
Why thanks.
I don't know if I can, but I'm doing it. So there you go. Just take next week off. Okay. All right. So there's all real numbers except x equals 3 and negative 1.
Yes, that's
Oh, okay, I wasn't in on the
Right.
joke here.
I gotta play ball.
Nah.
You fall asleep all the time.
Just because Mr. Wood authorized it.
What's that?
Just because you authorized us to.
Right. That's all it is. Yeah. All right. So now let's identify any vertical asymptotes or holes.
You refuse to leave.
Okay. Vertical asymptotes or holes. Okay. So, do we have any vertical asymptotes? Or do we have any holes?
Yes.
Okay. Where do we have a hole, Greg?
Well, negative x minus 3 and x minus 3 cross out.
Aha. So since the x minus 3's can cancel, that means we have a hole
1.
that has a coordinate. Nope, the x minus 3. So it's a hole with a coordinate 3, and that we're going to have to come up with the y coordinate here. I'll show you that in just a second. The x plus 1, does that cancel out? No. So what does that mean happens at that from here? What do we have there? If it's not a hole, what's it got to be? It's got to be a vertical asymptote. Okay, it's a vertical asymptote at x equals negative 1. Okay, so we have that vertical asymptote.
We have a hole.
Yes. The reason why we do is because
Because we have the X.
they will cancel.
Yeah.
Okay. But the thing is, how do we figure out what the y coordinate is for the hole, right? We know what the x coordinate is. It's got to be 3 because that's where it happens, right? At x equals 3. But what's the y coordinate? Well, here's what we're going to do. Okay, we're going to kind of imagine canceling out those x minus 3's, and what's going to be left? We're going to have x plus 3 over x plus 1. And now we're going to plug that 3 in. So it'll be 3 plus 3 over 3 plus 1. And so you get 6 over 4 or 3 over 2 when you simplify. So that's the y coordinate. It's 3 over 2. It's the number that you get when you, oops, sorry, I see one. There it goes. It's number that you get when it simplifies. Okay, when you can't, you imagine, again, we kind of like imagine canceling out those x minus 3's where we left with x plus 3 or x plus 1. And we can plug in the 3 now with no problem. We get 6 over 4 or 3 halves. So that's the whole's coordinates. All right. Keep moving here. We have to identify horizontal asymptotes or slant asymptotes. Okay. So this is where we look at the degrees. What's the degree of the numerator? Let's go to Stephanie. What's the degree of the numerator here? 2. What's the degree of the denominator, Stephanie? 2. So the degree of the numerator is the same as the degree of the denominator if the degree of the numerator is the same as the degree of the denominator. The ratio of the lead coefficients is our horizontal asymptote. So, Stephanie, what is the lead coefficient here? Lead coefficient, like the number in front. 1. What's the lead coefficient here? So it's 1 over 1. So the horizontal asymptote at y equals 1. Okay.
Well, what's the for the whole, what's the last?
3 halves.
3 halves.
3 halves. Okay. I guess I can circle this too because that's going to be an important graph as well. Okay. All right. We've got to find the zeros and then we're ready to graph. I'll put the zeros right here. Okay. So zeros, right? We set the function equal to 0. So 0 equals, I'm going to use the factored version. Okay. 0 equals x minus 3 times x plus 3 over the x minus 3 times x plus 1. Okay. And again, a function can only ever equal 0 and, when its numerator equals 0. So I'm just going to set the numerator equal to 0 here. Okay. And so it's x equals 3 and x equals negative 3. But remember that 3 is not, it's restricted from the domain. Why is 3 restricted from the domain? Because a whole at 3. So we're going to cancel out, we're not going to include that 3 as 0, just the negative 3. Just the negative 3 is a 0 there. Okay? Restricted from domain. Okay, so that's the idea there. It's restricted from the domain, so we throw it out. And now I can finally graph. Okay? So, first we're going to graph our vertical asymptotes, which is just at negative 1. So there's my vertical asymptote at negative 1. Okay. We also have a horizontal asymptote at y equals positive 1. Okay. And then we have a whole at 3 comma 3 halves. Let's see, here's 1, 2, 3. And let's see, there's 1, there's 2. So 3 halves is going to be right here. How do you graph a whole? You draw a circle, yeah. Boom. Okay? A whole is like graphing a point, except it's like a non-point. We're showing there is nothing here. So you open circle. What's that?
So it's a point, but it's not a point.
It's a point, but it's not a point. I knew you would understand. No, it's a non-point. Okay, but we want to show that it's there. But the good news is you can use it like it's a point. So what I mean by that, Carlos, is like, normally when we have this vertical asymptote, I tell you guys to pick a point to the left and pick a point to the right. Well, we already have a point to the right. So we know if I have this point here, then I know that my graph's going to go like this. It's got to go through the hole and then continue on. But I'm not going to actually, fill in the hole there because it's part of the graph. The hole. So we got that hole there. And we know most likely that our graph's going to probably be down here, but let's just check to make sure. So I'll plug in negative 2. So g of negative 2 here is going to be, let's see here, negative 2 squared minus 9 over negative 2 squared minus 2 times negative 2 minus 3. Okay. So that's just going to be 4 minus 9, so it'll be negative 5. And that's going to be 4 plus 4, so 8 minus 3, so that'll be, 5. And so you get negative 1. So you get the point negative 2, negative 1. So negative 2, negative 1, there's a point right there. And so, sure enough, we get that nice graph. Oh, and I forgot to graph. There's negative 3, 0, 1, 2. There's negative 3, 0. I also have the 0, too. I guess I could have just used the 0 point, actually, now that I think about it. I forgot to graph that 0. Okay. So there's the graph. All right. All right. Questions on that? All right, we're going to do one more together from our book, and I'll assign you one for homework tonight. Okay, so we're going to do one more together from the book, and then we'll, from our book. Okay, and then I'll assign you guys one for homework tonight. So on page 411, or thereabouts, let's see, maybe not exactly 411. Yeah, not 411. We'll skip over to page 4. Let's go to page 413 and do number 10. Okay, let's do page 413, number 10. Okay, so page 413, number 10 is what we're looking at here. We're going to do one together.
With my page right here.
How's your chin feel?
Okay. Say, Josh, how does your chin feel? Does it hurt? No? Okay. You like fell asleep on top of your bottle there. It's pretty impressive.
He's out too.
Yeah, the fonts is a little shorter. I can punch it a little bigger.
Is that right? That's impressive.
I had a friend, sorry, like who would sit down like this. Fall asleep. I don't know how he fell asleep like this.
And just like sitting
no,
up.
Like staying still, like he
Wow.
wouldn't move. I couldn't. Some people can.
That's impressive. I guess you're tired now. Okay. So here's number 10. We're going to go through this again. So what are the pieces that we need, right? What are the things we want to find? We have to describe the domain first. Okay. So what's the domain for this function? Or what are the x values that are going to give us problems here? What do we think? What x values will give us a problem here in this function? Specifically look at the denominator, right? We don't want the denominator to be 0. So what x values will make our denominator 0 there?
413.
Yeah, page 413. Okay. What are the x values that are going to make our denominator equal 0 here?
2 and negative 2.
2 and negative 2, that's right, okay? So we can say the domain is going to be all real numbers, right? Anything's possible, anything's good for x, except 2 and negative 2. Okay? All right, good. So then from those two domain restrictions, that means those are going to be either vertical asymptotes or holes. I'll put parentheses on that because one could be a hole, both could be a holes, or neither of them could be holes. Okay? Can someone help us out here? At 2, for example, is 2 going to be a hole or a vertical asymptote? Which one?
Negative 2 is going to be a hole.
Negative 2 is going to be a hole? How do you say that?
Because the negative x equals negative x minus 2 cancel out.
Okay, great that you noticed that. But it's going to be then 2 that would be the hole because it's the 2 that then with the minus 2 makes 0 there. So it's at the 2. So we have a hole.
Like the opposite value that makes like the...
It's kind of like the 0 of this factor, the 0 of this factor. So the hole is at 2 comma something, and we'll figure out what that something is in just a second. All right, great. And so then where is our vertical asymptote going to be?
It'll be negative 2?
Yeah, it's at the x equals negative 2, the other value there. Okay? that negative 2, you can't cancel its factor out and cancel out. The positive 2's factor, that x minus 2, they do cancel out, but the x equal to negative 2, its factor here does not cancel out anything. So that's a vertical asymptote. Okay. So now, remember for the holes, what we would do is we would imagine canceling out those x minus 2, and that would leave negative 3x over x plus 2, and now we'll plug that 2 in. I'll do it this way. So it's going to be negative 6 over 4, or negative 3 halves. Okay, just like that. Okay, so there's our hole. All right. Next, we're going to look at the horizontal asymptotes, or if we have a slant asymptote. Okay. What is the degree of the numerator here going to be?
The degree of the numerator 1.
So, yeah, if you see just the x there, but don't forget this x is going to multiply with this x.
So it'll be 2.
So the degree is going to be 2. Okay, so this problem's nice in that it's already factored for us, but it's tricky because it's not multiplied out and we don't know what the degree. You have to think about it a little more. What's the degree of the bottom going to be?
2.
Also 2. Very good. So the degree of the numerator is the same as the degree of the denominator. So then our horizontal asymptote is the ratio of the lead coefficients. Okay. What's going to be the lead coefficient in the numerator? Yeah, good. What's going to be the lead coefficient in the denominator?
1.
Yes, very good. It's a 1x and a 1x, so it'll be multiplying together. So negative 3 over 1, or just negative 3. Okay, good job, guys. All right, so let's keep it up here. We also want to determine the zeros, too. So let's take a look if we can find any zeros. Okay, so again, we said our function equal to 0. Okay, and we only need to worry about when the numerator is 0, so it's 0 equals negative 3x times x minus 2. It's really just then negative 3x equals 0 or x minus 2 equals 0. Or in other words, x equals 0 or x equals 2. Okay. Again, the function here will only ever equal 0 when the numerator is 0. And that's being multiplied, so you can use that zero product property. Negative 3x equals 0, x minus 2 equals 0. And so then x is 0 or x is 2 when you solve there. Okay. But one of these zeros is a domain restriction. Which one's a domain restriction? Which one is restricted from our domain?
2.
The 2. So we throw it out. Only the 0 is a 0. All right, and now we're finally ready to graph. We have all of our pieces in place. Or finally have all of our pieces. So we're going to graph our vertical asymptote there at negative 2. Okay. We're going to graph our horizontal asymptote at negative 3. Okay. We're going to plot our hole, okay? It's like an open circle. So 2 and then negative 3 halves. So negative 1 and a half is negative 3 halves. So it's going to be right there. Oops, and I put a doggone it. There we go. Sorry, it's supposed to be an open circle. There we go. Open circle. All right, and so we can kind of see then the curve's got to go like this, right? It's got to go through there, hit that, and then go through like that. Okay. Ooh, except it's got to go through 0, 0. That's the 0. Never mind. We have the 0 there. Okay, my mistake. Sorry. So not that piece. We got to go through the 0 at 0. So like that. Uh-oh. Okay, there we go. Okay. Sorry, I got ahead of myself and I didn't graph the 0 there first. Should have done that. Okay. And we got to figure out what's happening here to the left. So I'm going to pick negative 3, that x value negative 3 there to see where we are, either above or below this horizontal asymptote. So I'm going to say f of negative 3. Got to figure out one more point. So we negative 3 times negative 3 times negative 3 minus 2 all over negative 3 minus 2 times negative 3 plus 2. So I plug negative 3 in for all the x's there. And we simplify. So let's see, I think that's going to give us, oh goodness. Negative 45 over 5, or in other words, negative 9. Oh, that's not going to fit on my graph. Well, make sure I typed that in right. Pretty sure I did. Sorry, let me just check here, make sure. Minus 2. X plus 2. Okay, and let me type in negative 3. Oh yeah, it's negative 9. Okay, so negative 3, negative 9 will be like, well, there's 7, 8, so 9 will be like right there. And so you can kind of just see it's going to go like that. That's what your graph will look like then, something like that. Okay.
How'd you get 45 in the numerator? Negative 3 times negative 3 is 9.
Is positive 9, and then negative 3 minus 2 is negative 5. So 9 times negative 5. Okay? So, that's that. I'm going to have you guys do, let's see here. I don't really care either one. 8 or 9, whichever one you want to do there. Okay, let's just say 8. I know, Greg, you already did number 8, right? But you guys do number 8 for your homework, okay? Just number 8 there.
Can our homework be to get more naps?
Yeah, right. Yeah. Your other homework is to get some better sleep. Okay, because some of you guys, woo. I mean, granted, I know it's math, and this is harder stuff, so everyone just wants to. It's pretty dry, you know. But okay, so number 8, page 412. All right. I'm sorry this is so difficult, guys. I was not anticipating it to be this difficult, so
What's up after this?
I apologize.
What's up after this?
Right. So what's next? You're saying, like, what are we gonna maybe look at tomorrow? Some. Well.
Or like the next unit?
The next unit is exponents and exponentials and logarithms, so that'll be pretty tricky too.
We'll do it with what?
Mm-hmm. Yes, let me get those back to you here. I've got them graded. A handful of people still have to finish though. Like Amanda, I think you weren't quite done yet, right? Yeah, so I gotta get you in. And then I think